Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question 16C, which is in the trigonometry section. I'm not going to edit that. Mistakes get made. So it's question 16C. Let's look at the question. So question 16 had said, solve each triangle and round your answers to the nearest tenth of a unit. And 16C gives us this diagram showing triangle GNJ, or maybe GJN, whatever it is. And then it gives us this information. So it gives us all three sides. And of course, if we're solving a triangle, it means we need to find all the missing angles and all the missing sides. Well, none of the sides are missing. So when we're done this question, we will have found all measures of those three angles. So I'm just going to label this diagram. If this is vertex G, this must be side G. Vertex J, so this must be side J. And then vertex N, so this must be side N. So what tool am I going to use from my trig toolbox? Well, I obviously can't use the Pythagorean theorem or any of the SOHCAHTOA basic trig because I don't know if I have a right angle triangle, and those only apply if it's a right angle triangle. And that means I'm using either sine law or cosine law. To use sine law, I would need to have a complete pair of a vertex with its opposite side. So obviously I don't have that because none of the vertices are known, so none of the angle measurements are known, which means I can't possibly have a pair that would allow me to use the sine law. And that means I have to use the cosine law. So let's review what the cosine law is. So here it is. It's the cosine law as we normally see it. But in this case, I don't have an angle, so I can't substitute an angle and solve for a side. I'm going to have to rearrange it so that I can substitute the sides to solve for the angle. So you may have memorized this equation in its rearranged formula already, but just in case you haven't, here it goes. So first of all, I'm going to pick a side to start with. I'm going to start with G. So right now, this is what my equation looks like. So I'm emphasizing G. So G squared equals J squared plus N squared minus 2JN cosine G. And again, the key to using the cosine law is that the side represented on the left is the same as the angle represented in the cosine statement. So before I do any substitution, though, I'm going to rearrange this because my goal is to find G. So what I want to do is I want to isolate cosine G as best I can. So what I'm going to do is I'm going to take this entire term, 2JN cos G, that's a single term because it's multiplied together, and I'm going to add it to both sides. Right now it's subtracted, so if I add it, in other words move it to the left, it becomes positive 2JN cos G. And while I do that, I'm going to take G squared and subtract it from both sides. So this is what my first step to the rearrangement looks like. And then, because my goal is to isolate G, or actually I'm just going to isolate cosine G, and then it's very easy to get G. Now I need to get rid of the multiplication by 2JN. And that means I need to divide on both sides by 2JN, divided by 2JN. And that means my rearranged cosine formula for this question is that the cosine of G is equal to J squared plus N squared minus G squared, all divided by 2 times J times N. So that's the rearranged cosine law that helps me find an angle if I know three sides, and that's exactly the situation I have here. So now I'm going to start substituting into my formula so I can solve. So I'm just going to put a line here, mentally I guess. So cosine of G is equal to J squared plus N squared minus G squared divided by 2 times J times N. So now I'm going to substitute in. So J was 15, N was 16, and G is 17. So now this gets typed into my calculator, and of course, even, all this math we've already done, be careful that you are very comfortable using your calculator so that you can do this reasonably quickly and accurately. So I'm going to type in 15 squared plus 16 squared minus 17 squared, and then press equals. So the numerator is 192, and then 2 times 15 times 16 for the denominator is 480. So I'm going to get that as a decimal. So 192 divided by 480 is 0.4. So now I can actually find angle G. So the cosine of G is 0.4. So to find G itself, I need to undo cosine. And the way we undo cosine is by doing inverse cosine on both sides. So inverse cosine of 0.4. And now I just double check my calculator's in degree mode. Ooh, and it wasn't. Good thing I checked. So if I do second function cosine on 0.4, I get that angle G is 66.4 degrees. So now I know that angle G is 66.4 degrees, and I can use that information to help me find the rest. So let me just clear the page a little bit. There's my triangle, and now I know that this is 66.4, and I'll put my little labels back on. This was G, this was J, and that's N. So now that I know angle G, I now can use the sine law. And again, the sine law, I can use it now because I have an angle measurement and also the measurement of the side opposite it. So for this question, of course, we're not using triangle ABC, so let me rewrite the sine law properly using the letters of this question. So sine G over little g is sine J over little j, and that's sine N over little n. So because I have all components of G, let's sub those in. So G, sine G is sine 66.4 over side G, which is 17. And let's do J first. So I don't know angle J, but I do know that side J is 15. So now I'll solve. So what I like to do is I like to do as much math without my calculator before I pull out the calculator. So because I have a fraction equal to a fraction, that allows me to cross multiply. So I'm going to multiply 15 times sine 66.4. Again, I'm not actually doing the math in my calculator yet. I'm going to save that till the end so that I don't have to keep writing like weird long decimals. So that's what I get when I cross like this and cross like this for cross multiply. Now I want to isolate sine J, which means I need to get rid of multiply by 17. And of course, to get rid of multiply by 17, we do divide by 17. Boom. And that gives me the value of sine J. So at this point, I am going to calculate it in my calculator. 15 times sine 66.4 equals, and then divide by 17. So now I know that sine J is 0.8086. And now I just have to find J, which means I need to undo the sine operation, which means I do the inverse sine operation. So that will give me the value of angle J. Boom, boom. And my calculator tells me that it is 53.95. So let's say that it's 54.0 degrees. So now that I know angle J, I could use the 180 rule to calculate the value of N. And there's nothing particularly wrong with that. But I'm going to save that. I'm going to use the sine law again, because if I calculate the angle N using the sine law, it's really quick for me to check that my angles add to 180. So it's a really fast way of checking that my math is right. So now let's find angle N. And again, we're going to use the sine law. And I'm going to go back and use sine G. So sine G was 66.4. And little g, the side, was 17. And I'm looking for angle N. But I know side N is 16. So just like before, I'm going to cross multiply. So 16 times sine 66.4 is 17 times sine N. And I want to isolate the trig part, so divide both sides by 17. And then I can start using my calculator. So 16 times sine 66.4 divided by 17 is sine N. So calculating that, I get a decimal of 0.8625. And then to find N, I need to undo the sine operation, and that's done by inverse sine. And then in my calculator, inverse sine, I get that angle N is 59.59, or 60 degrees. Oops. Sorry, my calculator's right. My brain is wrong. I misread what my calculator said, which is good. because otherwise we had a problem. My calculator says 59.59, so this is actually 59.6 degrees. So remember how I didn't use the 180 rule? So now that I think that this is 59.6, look how easy it is for me to, in my calculator, really quickly add up these three angles and make sure that they add to 180 degrees or within a tenth or so, because you might have some rounding concerns. But in this case, I get exactly 180 degrees, which is awesome. And so therefore, the question was to solve the triangle. I found all three missing angles, and that means I've done the question. So I hope that was helpful, and I'll see you in the next video.